Hello everyone, my name is Ankush. I completed my master's from IIT Rupert, and today I'm here to discuss about the previous year questions, which are very important and repetitive kind of questions, so that you can enhance your scores. The objective of this video series is to enhance your scores above 90%, and I hope this video will help you a lot. So in this video, I'm going to discuss a chapter that is carbon and its compound, very important chapter. So in this chapter, we will discuss the question from the MCQ to the 5-mark questions. So if you see the previous year paper, so there we got question from the 1 mark, 2 mark, 3 mark, 4 mark and 5 mark question, and I will try to discuss all the different type of questions in this chapter. So let's start the topic with our MCQ questions. So the first question we are having is option. So this is a question number 1. Next we are having question number 2, that is also 2024, and in this question we have to find out. Now consider the following statements. Consider the following statement about the homologous series. Now we have to tell about the homologous series of carbon compound. Now the first point, the succeeding members of homologous series Y differ by CH2. That's correct. In a homologous series, the consecutive members of homologous series, they are differ by the formula unit of CH2. So option A is correct. Now in option number B, the melting point and boiling point increases with increase in molecular mass. Yes, in homologous series, chemical properties of all the compounds are same, because chemical properties are defined by the functional group. So for a given homologous series, functional group remains same. Therefore, their chemical properties will remain same, but there is upgradation in the physical properties like the melting point, boiling point, their densities, etc. So option number B is also correct. Option number C, the difference in molecular masses of two successive members is 16 U. It's not 16 U, it's 12 U. Now option number C is wrong option, and now we can eliminate the options. Now in whatever option C is available, that is not our answer. So C is available means this is not the correct answer. This is also not the correct answer. This is also not the correct answer. Only correct answer left is A. And also if you check D option, so that is also wrong. Why? Because these two members are not the successive member of alkyne series. So option number D is correct, but we are not having any choice which is having A, B and D. So the correct answer we are having is A and B. That is our correct option. Now the next question. The structural formula of the cyclohexane. So cyclohexane, structural formula of cyclohexane is, the formula of cyclohexane is C6H12. It is having a similar kind of formula as that of alkene members. So C6H12, and cyclohexane is what? It is a cyclic saturated hydrocarbon, and if it is a cyclic saturated hydrocarbon means it should have all single bonds. So wherever double bonds are there, that will not be our answer. Double bond, double bond, double bonds are, therefore answer is what? This. And also you can check, there are 6 carbon atom. Each carbon atom is having 2 hydrogen. So 6 carbon atom and 6 into 2, 12. So formula is C6H12. So option number B is the correct answer for this particular question. So we can eliminate our options also by checking. If you don't know the formula, then you can eliminate if you know the certain basic fundamentals. So by elimination also we can get the answer for this question. Now let's discuss some few more points about that cyclohexane. In this case, sometimes they ask about the number of bonds. So if you see the number of carbon bond, carbon-carbon, how many bonds are there? 6. Carbon-carbon, how many bonds are there? Carbon-carbon is having 6 bonds. And carbon and hydrogen, we are having how many? Each carbon atom is making 2 bonds with the hydrogen. So therefore 6 carbon atom will make total how many? 12 bonds. And overall, how many bonds are there? 18. And all bonds we are having are covalent bond, because carbon forms covalent bond. So next question. Which of the following hydrocarbon is different from the others? Now in this case, we need to look for the general formula. Almost we are having all the hydrocarbons. Maybe they can be saturated or unsaturated. So means we have to look for the formula, that is CnH2n plus 2 or CnH2n or CnH2n minus 2. We need to see that which two compounds, right, which one of the following hydrocarbon different from other. So there must be one compound which should have a different formation of the formula. Now the first one, if you see, 4 2 8 plus 2. This is what? Alkane member. That is what? Butane. Next, 7 to the 14. This is what? This is our alkene member. This is our alkane member. 5 to the 10, 10 plus 2, 12. This is also saturated hydrocarbon. 2 to the 4 plus 2, 6. This is also saturated. So A, C, D are saturated hydrocarbons. They belongs to alkane series, and this B belongs to alkene series, which is the different compound. So for this question number 4, the different compound other than these three compound is, that is B option. And the name of this compound is 7 carbon atom we are having, so heptene we can see. 7 means so heptene. The suffix for alkene is -ene, so the name of this compound is heptene. Next question. So question number 5. Now in this question number 5, this question is from again 2023 paper, 1 mark, and this question from the chemical properties of the carbon compounds. So in this case, select the saponification reaction we have to write. So this is the reverse of esterification. In this case, we take ester. Saponification means what? In this, esters are treated with sodium hydroxide, and which produce what? The sodium salt of carboxylic acid and alcohol. So in which case we are getting sodium salt of carboxylic acid? Yes, in this case, but along with that, it produces alcohol also. So the correct option we are having is what? This is our ester. This esters are what? Esters are the substances which are having sweet smell. Sweet smelling agents or substances are called esters. And the name of this compound is, it is ethyl ethanoate. When it reacts with sodium hydroxide, it produces what? Sodium acetate, or sodium acetate plus along with that sodium ethanoate, or along with that it produces alcohol. So this is the reaction of saponification reaction. So option C is the correct option in this case. Next question. Question number 6. This question is 2024 paper. So in this case, we have to balance the equation, and based upon that, we have to predict the compound. It's a good question actually. The 1 mole of hydrocarbon, we don't know which hydrocarbon, but saying 1 mole of hydrocarbon on combustion in air. When we are doing combustion of, let X be that hydrocarbon, and when we are burning that in air means oxygen, produces 2 moles of CO2. 2 moles of CO2 it is producing, plus 2 moles of water it is producing. We have to predict, and a large amount of heat, it is generating large amount of heat and light. We have to find out that hydrocarbon X. And we know that in our lower grades we have studied the laws of chemical combination, in which we have studied that the number of atoms on the reactant side and product side must be equal, and no new atom can participate in a chemical reaction. So means we can say in product side we are having carbon, oxygen, hydrogen. So on the product, in the reactant side also, we will have same number of carbon, hydrogen and oxygen. So in this case, we know X is what? It's already mentioned, it is what? Hydrocarbon. So means it is made up of carbon and hydrogen. So how many carbon it should have? The total number of carbon which we are having on the right hand side. How many carbon we are having? 2. So it must have 2 carbon. And how many hydrogen it should have? So how many hydrogen? 2 into 2, 4. So 4 hydrogen it should have. Oxygen, now we can check oxygen balancing also. So 2 and 4 plus 2, 6. So it should react with 3 oxygen molecules. Now it is balanced. And the name of hydrocarbon of X we have predicted, N equal to 2 means eth, and the formula is CnH2n. So the compound name is what? Ethene. So name of the compound is what? Ethene. So answer for this is option number B, that is ethene. This is how we can predict the compound by using the chemical equations. So next, in the similar manner, in future if you get the question from, maybe you can get alkanes also or alkynes also. So this is how you can predict by balancing the equation, by balancing the number of atoms on the reactant product side. Right. Hydrogen cannot be part of this oxygen, because oxygen itself, it's in a molecular state. So the reaction itself, they are saying it's a combustion reaction. So in combustion reaction, the given substance react with oxygen. So that's why whatever carbon, hydrogen we are having, that should be part of this X. So this is how we can predict the answers. Next question. That is from 2023, 1 mark question. Select the group of unsaturated hydrocarbons from the following. Unsaturated hydrocarbon itself, it is mentioned. That means it should be ene or ine. it should be ene or ine, means wherever we are having ane, the compound belongs to whether it is alkane series or cyclic compounds of saturated cyclic compounds, that will not be our answer. So we can eliminate the option also. Ethane. So means it is not, all the members are not a member of what? Unsaturated hydrocarbons. So this is not our option. Next, here cyclohexane, again saturated. So this is also not our answer. Here is what? Ene and ine, all are unsaturated. So answer is this. So we don't even need to check the option number D. And by the way, if we check option number D, so methane, which is our what? Again, saturated hydrocarbon. But in this question, we are looking for what? Unsaturated hydrocarbons. The group of unsaturated hydrocarbon we are having is ethene, propene, and butane. So this is the how we can answer this question. Next, consider the structure of 3 cyclic compounds A, B, and C given below. Select the correct option from the following. So we have to select the correct option. Now what are the options? Let's see. The option number 1, A and C are the isomers of hexane and B is benzene. Isomer. So what are the isomers? Isomers are what? Isomers are the compounds which are having same molecular formula but different structural formula. Now he is saying A and C are isomers. So where is A? This is A and this is C. They are not isomers. Why? Because you can see the chemical formula both is different. The chemical formula, if you see molecular formula, both are having different. So they cannot be our isomers. So option number A is not the correct option. Option number B is eliminated. Now next we are having option number B. A is an isomer of hexane. A is an isomer of hexane. Again, isomer of means same chemical formula but different structural formula. The formula of this A is what? C6H12. But hexane formula is what? The formula of hexane is what? C6H14. So different chemical formula means they cannot be our isomer. Option number B will not be our answer. Next, A is a saturated cyclic hydrocarbon. Yes, it is cyclic hydrocarbon and saturated. All single bonds are there. And B and C are the unsaturated cyclic hydrocarbon. Both are cyclic and they are having double bonds. So you can say they are what? Unsaturated hydrocarbon. So option number C is the correct answer. And if you see option number D, so in option number D, A is a cyclohexane. That's true. B and C are the isomers of benzene. No. The benzene the formula of benzene is C6H6. And if you see this formula and this chemical formula, both are different. So the chemical formulas are different, so they cannot be the isomers. So the right option we are having is option number C. So that is our correct answer. So this is how we can answer such questions. Next. Question number 9. Now this question number 9, again it is from the chemical properties of the carbon compounds. The above reaction, the reaction which is given there, is an example of what? So you can see here, this is an example of the methane. Methane means saturated hydrocarbon. Generally saturated hydrocarbons they are not much reactive. They don't react with the reagents easily. But in the presence of sunlight and at a high elevated temperature, they can do a very fast reaction with the chlorine or with the halogens. So this is a chlorine is coming and doing what? It is substituting one of the hydrogen and becoming a part of the methane, and it becomes what? Chloromethane plus HCl. So this is what? It is a substitution reaction. In this case, what is happening? One chlorine is substituting hydrogen and becoming a part of methane and turns it to chloromethane. So this is our substitution reaction, not addition reaction. There is a difference between substitution and addition reaction. Addition reaction means what? Two different compounds combine together and form a single product. But in substitution reaction, they just rearrange the atom, they just displace the atom, they just replace or substitute the atoms and form more than one product. So this is what our answer is, substitution reaction for this question. Double displacement reaction that we have studied in chemical equations. Next, now we are having 2-mark questions. So question number 1, that is from 2022 paper, and the question says that, now in this question, the carbon prefer to share its valence electron with the other atoms of the carbon or with atoms of other element rather than gaining or losing the valence electron in order to maintain the novel gas configuration give reason to justify this statement. So if you see the configuration of carbon, so atomic number of carbon is what? 6. And if you see the configuration of carbon is 2 and 4, the valence shell is having how many? 4 electrons, and it need either carbon need to gain 4 electron or carbon need to lose 4 electron. If carbon gain 4 electron, so by gaining of 4 electron, it will turn to a ion. That ion is what? C4. Gaining of electron leads to negative charge. So how many electron it is gaining? 4. So it will form what? Anion. Negative ion is called as anion. And similarly, if carbon gain 4 lose 4 electron, so by losing of 4 electron, it will attain positive charge C4. That is what? Cation. And this is a very popular question, that why carbon do not form cation and anions. The reason is, so if we talk about first gaining of 4 electrons. So if you see the nucleus of carbon, the carbon nucleus is having how many protons? 6 protons. And in orbit, it will have how many electrons? By gaining of 4 electrons, it will have 10 electrons. And for 6 electrons, it is not possible for the 6 electron to hold 10 electron and maintain the stability. So that's why it do not form anion. That's why it do not gain electrons. Now let's talk about the second part. Gaining or losing of 4 electrons leads to the formation of cation. So again, in nucleus, we are having how many? 6 protons, right? And losing of electron, that will leads to left with 2 electron in the orbit. And when it will lose the electron, we need to supply large amount of energy is required to remove electron one by one from the outer orbit of carbon, and which is practically not feasible again, because large amount of energy is required to remove these 4 electron and form cation, which is not feasible. So that's why carbon do not form cation and anions. Now how it overcome this problem? So by sharing of electrons. So that's why carbon share its electrons. Carbon can share electron with itself, or carbon can share electron with other atoms also, and that leads to the formation of sharing of electron, leads to formation of covalent bonding. So that's a carbon form covalent compounds. So that is the answer for this particular question. Next, write the dot structure of methane and ethene. So dot structure of methane and ethene. So to write the dot structure of methane, so methane is having formula CH4. Sometimes they provide formula, sometimes they don't provide formula also. So you should know the formulas of these basic compounds, right? CH4, that is methane. And now the dot structure means simply means it represents the outermost electron in the orbit of any atom. So for example, I am writing the dot structure of carbon. So carbon is having a valency. As we have written, valency of carbon is 2, 4. And if we talk about hydrogen, so hydrogen atomic number is 1. The valency of this hydrogen is having outermost orbit 1 electron. The dot structure for carbon will be, this is how we can represent. Dot structure means we will represent the free electrons in the outermost orbit, electron in the outermost orbit. Similarly, hydrogen dot structure will be cross. I am representing dot and cross so that there should be no confusion. So now let's draw the dot structure of carbon and hydrogen together to form methane. So this is carbon, this is carbon, this is carbon, this is carbon, 4 electron. And now in order to complete the octet, means 8 electron outermost orbit, either carbon need to lose or gain, that we already discussed. Carbon cannot lose or gain electron. Then what it will do? It will try to share the 4 electron. So what is the second element we are having in compound is hydrogen. But hydrogen is having only 1 electron. So hydrogen can give only 1 electron. Same thing, 1 more hydrogen. And here we need 4 electron. Hydrogen, carbon need 4 electron, therefore it need 4 more hydrogens. So how they are going to form the structure? So hydrogen will share its electron, hydrogen will share its electron, and hydrogen will fulfill its state. And same way, carbon will also share these electrons. The shared pair of electron is a part of both the elements. So this shared pair will count in both hydrogen as well as carbon. So now line structure also we can draw for this. So the line structure for this will be what? The carbon, it will form 1 share pair of electron leads to single bond. So here we are having how many share pair electron? 1, 2, 3 and 4. Therefore it will form 4 different bonds. So this is a line structure. This is your dot structure for the methane. Next we are having is ethene. So the same concept we are going to use for ethene also. The same dot structure we are going to use for ethene also. So for ethene, the formula of ethene is what? Cn. The formula for ethene is C2H4. So now 2 carbon atom is having 1, 2, 3, 4. Similarly, one more carbon we are having here, which is having 1, 2, 3 and 4. Now carbon need how many electrons? 4 electrons. So apart from that we are having what? Hydrogen also. So in this case, if you see, the carbon is having how many C4, as we are having 4 hydrogens. So in this case, this side we are having hydrogen and carbon will share its 2 pair of electrons. Now in this case what is happening? Hydrogen, hydrogen, hydrogen and hydrogen. Now here hydrogen will share these electrons and form a single bond, because here they are sharing one shared pair of electron leads to a single bond. And carbon need total 8 electrons. So 2 plus 2, 4. 4 plus we are having here 1 extra electron we are getting from this side also. So that leads to total how many bonds? 8 electrons. Carbon is having 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. So this carbon atom is having 8 electron fulfilled. Same way this carbon also need to fulfill its requirement. So it is having 2 plus 4, 6, 6 plus 2 now 8. So this carbon is having 8 electron outermost orbit. This carbon is also having 8 electron outermost orbit, and hydrogen need to complete 2 electron in the outermost orbit. So dot structure of this will be this, and which can be further leads to 2 share pair of electron means double bond, 1 share pair of electron means single bond, and the compound name is what? C2H4. So this is the dot structure of ethene, and previously that is the dot structure of ethane. So this is how we have to draw the dot structure by keeping their outermost orbit number of electron balanced, or in case of carbon it should be 8 electrons. Now the next question we are having is, again the question is from chemical properties of carbon and its compounds, and question is from 2024, 3-mark question. So each question is having 1 mark. So you need to write the equation correctly. Chemical formula should be correct, and second thing, it should be a balanced equation. So if I talk about the first reaction, write the chemical equation for the following reaction given condition, giving the condition for the reaction in each case. So here you have to mention the conditions also. What are the conditions for the reaction? Now the first reaction we are having is what? Reaction of ethanol and ethanoic acid. So ethanol and ethanoic acid, we already know that when ethanol and ethanoic acid combine together, then they leads to the formation of the sweet smelling substances that are called as esters, and this process is called esterification. So what is the chemical formula of ethanol? Ethanol chemical formula is C2H5OH. When it react with ethanoic acid, that is what? CH3COOH. That is our ethanol. And this is we are having is ethanoic acid. And when both react, so esterification, it is a very slow process. Now to enhance the rate of reaction, we need to add in this case the catalyst. So here the role of catalyst is performed by the concentrated, we are using H2SO4 sulfuric acid. We are using concentrated H2SO4, and we are heating that solution, and which leads to the formation of. And also we know that sulfuric acid, concentrated sulfuric acid is what? It also act like in this reaction, the role of this sulfuric acid, one, it act like the catalyst which enhance the rate of reaction, means speed up the reaction. Second thing, it act like a dehydrating agent. The role of dehydrating agent is what? To remove the water molecule from there. So once the water molecule is removed from there, then it will lead to what? The formation of ester, and the ester it is going to form is C2, CH3, C2H5, CH3, double bond O, O, C2H5. So this is what? This is the formation of ester, and name of this ester is what? Ethyl ethanoate. The name of this ester is what? Ethyl ethanoate. Plus it is going to produce what? Water molecule. So if you check, it is already balanced equation. So that is the reaction for the first compound, the reaction of ethanol with ethanoic acid. Now we are having second reaction, the reaction of ester with base. So that is what? Reverse of esterification, that is called saponification. So in this case, we will take this ester and will treat that ester with sodium hydroxide, and that leads to the formation of the sodium salts of carboxylic acid, and these are what? The soap. What is soap? Soap are the sodium or potassium salts of carboxylic acid, long chains of carboxylic acids. So in this case, we are going to form the soap, and this process is called as saponification. So the reaction for this will be, we are taking ester, the ester which we formed in the previous example, that is ethyl ethanoate. So CH3, so here we are taking the ester CH3, C double bond O, C2H5. When this ethyl ethanoate, when it react with sodium hydroxide, then it is going to produce what? The sodium salt of carboxylic acid, CH3COONA, and that is also called as sodium ethanoate or sodium acetate. That is also known as what? Sodium acetate. Sodium acetate, or another name is what? Sodium ethanoate. And along with that, it is going to produce alcohol. So which alcohol it is going to produce? Ethyl alcohol or ethanol. So C2H5OH. So this CH3COONA plus C2H5OH. So it is produced what? Along with that, ethanol. So this is the reaction of the reaction of ester with the base sodium hydroxide. That is our the second reaction. Now the third reaction we are having here is formation of ethene from ethanol. So we are producing ethene from ethanol. So this reaction is what? That is called as our dehydration reaction. That is the chemical properties of the ethanol. When we treat ethanol, so in this the C part, we have to write the reaction between the ethene and ethanol. The formation of ethene from ethanol. So how ethanol can be converted to ethene? The name of reaction is called as what? Dehydration reaction, that we have studied in the dehydration reaction, that we study generally in the chemical properties of alcohol. So there what we do, we take ethanol, that is C2H5OH, and we treat it with hot concentrated H2SO4 sulfuric acid, and the temperature is around 443 Kelvin. So we heat it to a temperature of around 443 Kelvin, and as we know that H2SO4 is what? It is a dehydrating agent. Then what it will do? It will remove water from there, and once the water is removed, then what is left out? We are left with what? C2H4, and this C2H4 is what? That is our ethene. This C2H4 is what? Ethene. So this is how we can produce the ethene from ethanol. Again, name of reaction is what? Dehydration reaction. Which agent we are using? Dehydrating agent here is concentrated sulfuric acid, and it is a hot concentrated sulfuric acid. We are heating the solution of ethanol and concentrated sulfuric acid to a temperature of 443, and which speed up the reaction and turn to what? Ethene plus water. Because you're dehydrating agent, it will remove the water. So this is the third reaction of formation of ethene from ethanol. The question number 13, it's a bit theoretical type of question. What are the homologous series? What is homologous series of carbon compounds? Give an example and list its three characteristics. So homologous series is what? Homologous series are what? It is a group of organic compounds in which they are having same functional group, and because of the same functional group, they are having the same chemical properties, but they are having different physical properties, or there is an upgradation of the gradation in the physical properties of the compound. As the molecular mass increases, there is upgradation in the physical properties. So this is called as our homologous series. So family of organic compounds having same functional group and similar chemical properties, and there is an upgradation in the physical properties, that is called as homologous series. Now give an example of homologous series. Many homologous series we are having here. We are having series of alkanes. You can give any of the example: alkane, alkene, alkyne. Then after that we have studied haloalkanes. Then we have studied alcohol series. Then we are having aldehyde series. Then we are having ketone series. Then we are having carboxylic acid series. Carboxylic acid series. Now in the second part of the question, list 3 characteristics. Okay, as we have written, so we'll write there also suffix also. What is the suffix for this? Ene. This is what? Ane. Alkane suffix is ane. Ene. Then ine. Then haloalkane is same. You have to add the chloro, fluoro, bromo. And in this case, it acts as a prefix. In other, the suffix we add as a suffix, but in haloalkane series it is add as a prefix. For example, if chlorine is attached with the methane, then we call it chloromethane. The chloro word comes first, prefix. Alcohol is having ol, aldehyde is having al, ketone is having on, carboxylic acid is having oic acid. If we talk about their functional group, right? Functional group we are having here in this case of alcohol, OH. In this case, we are having aldehyde, we are having CHO, which is written as like this, also C double bond O, CHO, that is written as O and H, C double bond O and H. Ketone is written as C double bond O, and here any of the alkyl group will come. In case of ketone, alkyl group will come, means it should have at least one carbon atom, and that is the reason ketone series, the first member of ketone series is propanone. So ethanol, methanol is not existing for ketone series. The first member of ketone series is propanone, because at least one carbon atom should be there at the ends of this functional group of ketone, that is C double bond O, and we are having R. Oic acid functional group is COOH, or which can be written as C double bond O, OH. So these are the some basic information about these the homologous series, but it is not relevant to the question, but we have discussed as it is generally question comes from these particular points also. So this thing you should know. Next is, what are the characteristics of homologous series? So if we talk about the compound, functional group same, but in this case, first thing is that the properties of the compound in homologous series, they are having same chemical properties. Same chemical properties. Second is, there is an upgradation in the physical properties. Third important is that consecutive member of homologous series, they are differ by a structural unit of CH2, and molecular masses of the consecutive series differ by molecular masses of the consecutive member of homologous series differ by a mass of 14 U, and they are having same functional group. They are having same functional group. So these are the few properties, that characteristics that you can mention in this question, as they are having same functional group, and functional group is decided by the heteroatom, which will decide the chemical properties and the chemical properties of the compounds in the series. So this is how we have to tackle this question. Next, we are having question number 14. Again, it is a 3-mark question, 2022 paper. Organic compounds are given 1 and 2. The question is, find out we have to name the functional group present in their compounds. What functional group is present here? CHO. CHO. So which functional group is present over there? CHO. CHO is a functional group of which homologous series? Aldehyde series. Right, it is a aldehyde series. So it is a aldehyde series. Write the general formula for the compound of this functional group. The general formula for the aldehyde series is H2N plus 1 CHO. That is the general formula, but here you have to keep in mind N will start from 0. N will start from 0. When you put N equal to 0, you will get the first member of aldehyde series. To get the first member of aldehyde series, in this general formula, we have to put N equal to 0. It should not start with 1. If you start with 1 directly, series will start with ethanol. But methanol is also the member of aldehyde series. To get the first member, that's why we should put N value starts from 0, 1, 2, 3 like that, integer values. So this is a general formula for the compound of this functional group. Next, state the relationship between these compounds and draw the structure of any other compound having the similar functional group. So these are what? These are the, what is the relation between them? Both the compounds are what? The compound number 1 and 2, they are the first and the, sorry, not the first, and the second and the third member of same series. Second and third member of aldehyde series. They are member of same aldehyde series. They are member of both the same series, that is aldehyde series. So that is the relationship in these compounds. And if you see there, the formula is differ by CH2 also. Their molecular masses will be differ by the 14 unit because they are the second and third member, two consecutive member. So we can write one more member of this series. So we can write the first member of the series. The first member of the series, second, third is already there. You can write any of the member. The first member of the series of the similar functional group is your HCHO. HCHO is what? That is methanol. Methanol, that is our first member. Or you can write another member, fourth member. Fourth member will be what? CH3, CH2, CH2, CHO. So that is what? Butanol. So any of the compound you can write. Right. So we have to draw the structure also. So structure for this one, methanol, structure will be C double bond O H H. So HCHO, that is the structure of our methanol. And if you want to write the structure for ethanol, then carbon, carbon, propanol, butanol. So all will be taken by hydrogen, hydrogen, double bond O and H. So H, 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 H. So this is the structure of your butanol. So any of the structure you can draw in this particular question. So this is how 3-mark question we have to attempt. Next question number 15. Again 2023 4-mark question. Carbon is a it's a 4-mark question. So in this question, carbon is a versatile element that forms the basic of all living organism and many of the things we use. A large variety of the compound is formed because of the tetravalency. Compounds of the carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine and many other compounds. Answer the following question. Question number 1. What are hydrocarbons? So hydrocarbon is what? These are the compounds made up of hydrogen and carbon in different number of atoms. So right, the hydrocarbons can be saturated or unsaturated. Saturated hydrocarbon having single bond, unsaturated hydrocarbon having double and triple bond. Saturated hydrocarbons are very less reactive. Unsaturated hydrocarbons are reactive in nature. Saturated hydrocarbon, they undergo complete combustion. Unsaturated undergo incomplete combustion. Saturated hydrocarbon produce that blue color flame and hot flame, and unsaturated hydrocarbon produce yellow color flame because of the incomplete combustion, and the temperature of flame comparatively will be low and it produces soot particles, smoke also. So these are the difference between the different type of hydrocarbons. But as question is of 1 mark, so we can give simply a definition or the classification. That's it. Next we are having a list 2 properties by virtue of which carbon can form large number of compound. So that is the versatile nature of carbon. If you see in our surrounding, so most of the things are made up of carbon. Most of the compounds generally made up of carbon. So reason for that versatile nature of carbon is that carbon can form the bond with itself. Right, carbon can form a bond with itself, and the bond will be very strong and stable. And this unique property of carbon forming a bond, that is called as what? Catenation. So the first reason we are having here is what? That catenation, the first property by virtue of which is what? That is catenation. Catenation is what? It is a unique property of carbon to form a strong and stable compound with itself. And the second we are having is what? It is having tetravalency. Carbon is having valency 4, that is tetravalency. Because of that, carbon can form 4 different bonds with carbon itself or some other monovalent element also. It can form bond. Apart from that, it can form bond with what? Hydrogen, oxygen, nitrogen, sulfur, chlorine, and many more compounds. And apart from that, it not only form these compounds, but the bond formed by carbon is very strong, because the reason is that along with tetravalency, the size of carbon is very small, and due to small size of carbon, it is having a strong pull on the nucleus, having a strong hold on the shared pair of electrons. That's why it form a stable compound. And in case of catenation, it not form the carbon-carbon bond, but also it can form long chain structures, it can form cyclic structures, it can form branch structures, and apart from that, carbon can form single bond, double bond, triple bond. So that leads to the formation of large number of compounds. So the two characteristics we are having is catenation, and the second we are having is what? Tetravalency. So as the 1 mark question, so no need to give much explanation, but this explanation we are giving so that you can tackle some other questions if you get in future. So next question. So next we are having what are the structural isomers, and write the structural isomers for the butane. Structural isomer means having the same chemical formula but different structural formula, that are called as the structural isomers. And we have to write the butane. So the butane structure is what? CH3, CH2, CH2, CH3. That is the one formula of butane. And isomer we can write as CH3, CH, CH3, and here one more CH3. If you see in both the structure, both the compounds, structures are different, but if you see the chemical formula, so it is what? C4, 3 plus 2, 5, 5 plus 2, 10, C4H10. Here also C4 and 3 into 3, 9 plus 1, 10. So in both the cases, the chemical formula is same, but the structural orientation is different. That's why they are called the structural isomers. So these two are the structural isomers of the butane. So this is how we can tackle this question. Next we are having, name the simplest saturated hydrocarbon. Name the simplest saturated hydrocarbon, draw its electron dot structure, and which type of bond exists in this compound. Saturated hydrocarbon and simplest. Simplest means the first member, right? So first member of saturated hydrocarbon, the first member of saturated hydrocarbon we are having is what? That is CH4. Saturated hydrocarbon means alkane. The first member we are having is what? CH4, and that is called methane. Draw its dot structure. The dot structure, how to draw? Carbon is having how many free electron in outermost orbit? 4. Hydrogen is having how many? 1. Hydrogen is having 1. So if you see, when they are sharing their electrons, so hydrogen, 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 and it is forming a single bond, and carbon is going to share these pair of electron and having 8 electron in its outermost orbit. So this is the dot structure of your methane. And which type of bond exists in this compound? As you can see that there is a sharing of electrons. So sharing of electron leads to what? Sharing of electron leads to which type of bond? That is a covalent bond. So which type of bond we are having? Covalent bond, and all are the single bond in this case, as it is a saturated hydrocarbon, and you can see one pair of electron leads to the formation of single bond. Next question, name any two mixtures of the carbon compound used as a fuel in daily life, means we are using that fuel in our day-to-day life, and of which above mentioned compound is an important part. So methane is an important part. Methane is an important part of is which fuel? So it's an important part of one natural gas, right? Methane is a very important natural gas. One is mixture is what? Natural gas, we call it what? CNG, compressed natural gas. And second, biogas. So both are what? They are used as a fuel, and both are having the major component in them is your methane. So one mixture is natural gas, that is CNG, compressed natural gas. Second is biogas. Third part of the question is, in which homologous series of carbon compound can this compound be placed? So we can place it in which series? alkane series, saturated hydrocarbon series, that is alkane series, and write the general formula. The general formula for this is what? CnH2n plus 2, that is the general formula for this. And next question, which type of flame is produced? As already we discussed in the previous question in case of the hydrocarbons. So this is a saturated hydrocarbon. Saturated hydrocarbon undergo complete combustion. Complete combustion leads to the formation of clean flame. Clean flame leads to the formation of clean flame means blue color flame. Complete combustion leads to formation of blue color flame. So what kind of flame? That is a luminous flame, right? And that leads to the formation of blue color flame. So that is the type of the flame is produced during the burning of this saturated hydrocarbon. So next question number 17, that is from 2023. Again, it's a 5-mark question. So the first part is, what happens when small piece of sodium is dropped in ethanol, and write the equation for this reaction. So now if you take ethanol, ethanol is C2H5OH, and if you drop sodium, sodium is highly reactive metal, if you drop sodium in that, then it leads to the formation of what? Sodium C2H5O Na plus hydrogen gas is going to form. So when we drop sodium in a ethanol, then that leads to formation of the compound, that is sodium ethoxide. The name of the compound is sodium ethoxide plus hydrogen gas is going to liberate. And how to test hydrogen gas? Whenever hydrogen gas releases, and if you light a matchstick near that, it produces the pop sound. So that is the test to confirm the gas produced during the reaction is your hydrogen gas. So now we have to balance it. We have to check whether it is balanced or not. As this side we can see 2 hydrogen are produced, we have to multiply with 2. That also multiply by 2. Multiply by 2. Now it is balanced. C2H5, 2Na, 2O and 2 hydrogen. So this reaction is now balanced reaction. So the first part is what? When sodium is dropped into the alcohol, ethanol, it leads to the formation of compound that is called sodium ethoxide, and hydrogen gas will produce, and the balanced equation for this is given below. Next question is, why is glacial acetic acid called so? So the actual name of glacial acetic acid is what? That is your ethanoic acid. Another name of ethanoic acid is your acetic acid, or it is also called as what? Glacial acetic acid also. Why it is called as glacial acetic acid? Because if you see, the ethanoic acid, the freezing point is very low. If you keep it in a temperature around 290 Kelvin or 17 degrees Celsius, then it starts freezing and it form a snow-like structure and which look like a glacier. That's why the term is given as a glacial acetic acid. Another question which comes from acetic acid is 5 to 8% solution of acetic acid, that is called as vinegar, which we use for the cooking purpose also, and that is what our vinegar. So this is the answer for the second part. Next question is, what happens when ethanol is heated at a temperature of 443 Kelvin in the presence of concentrated H2SO4, and what is the role of concentrated H2SO4? Just now in the previous question we have done this reaction where we have seen ethanol C2H5OH, and when you treat this ethanol and heat that to a temperature of 443 Kelvin using a concentrated H2SO4, and we know that the role of here concentrated H2SO4 is what? It is a dehydrating agent, and what it will do? It will remove water molecule from there and turn alcohol to C2H4, that is what? Our ethene. Means in this reaction what will happen? Alcohol will turn to ethene, means unsaturated hydrocarbon, and along with that water molecule will come out. So this is the reaction, and the role of sulfuric acid here is what? It act like, one is catalyst, second thing it is a dehydrating agent. So dehydrating agent, what is the purpose of that? It remove water molecule from alcohol. It is removing H2O from alcohol and turning it to the unsaturated hydrocarbon ethene. Fourth, write an equation showing the saponification. So already we have done saponification is what? Is a reverse of esterification. So in that reaction what we have to do? When we treat any ester, let's say we are taking ester CH3 COC2H5, that is our ethyl ethanoate, and when you treat that with sodium hydroxide, then it leads to the formation of what? It leads to the formation of CH3 COONA, sodium salt of carboxylic acid, that is what? Soap, plus alcohol C2H5OH, and this substance is what? Sodium ethanoate or the sodium acetate. So this reaction is your saponification reaction, which is used to the formation of soaps. So the next, this is the reaction for our, that when we drop the sodium in a alcohol, that leads to the formation of this compound, that is sodium ethoxide plus hydrogen in the balanced equation. Next, a compound X undergo addition reaction with hydrogen. So we are having some compound X. We don't know what is that compound, but some information is given. X undergo addition reaction with hydrogen. When you are taking X and you are adding hydrogen, and you know that addition of hydrogen, that reaction is called as also hydrogenation or addition reaction. Addition reaction with hydrogen that take place in the presence of catalyst, that is nickel or palladium, to form a compound Y, that leads to the formation of some compound Y having a molecular formula of 30. So molecular formula of Y is how much? 30 gram per mole. So that is also called as molar mass. Molar mass means mass of 1 mole of the particular molecule. X decolorize bromine water and burns with the smoky flame. Now X, and you know that when X decolorize bromine water, that means what? It is there's a bromine water test. When the bromine water is decolorized, means the given substance is what? Unsaturated hydrocarbon. So one thing it is clear from there, that X is what? It is a unsaturated hydrocarbon. And if you treat bromine water with saturated hydrocarbon, there is no change in the color. But if color is changing, that confirm that the given substance we have taken, that is what? Unsaturated hydrocarbon. Now this unsaturated hydrocarbon, and the second information is given, smoky flame, and we know that smoky flame produced by incomplete combustion. So which undergo incomplete combustion? Again, unsaturated hydrocarbon. So X is one thing, it is clear, X is unsaturated hydrocarbon. And that also we know that in addition reaction is what? Unsaturated hydrocarbon converts to saturated hydrocarbons by the addition of hydrogen in the presence of catalyst, that is nickel. Identify X and Y and write the chemical equation of the reaction involved. Now we are getting the Y, and the molecular formula of Y is 30. So obviously Y is what? Due to addition reaction, Y is produced, that is what? Saturated hydrocarbon. Saturated hydrocarbon. So we need to look for which saturated hydrocarbon can have the molecular formula 30. CnH2n plus 2, that is the standard formula of your saturated hydrocarbon. And we don't know how many carbon atoms are there, but we know the molecular formula of carbon is 12. So 12 into n plus molecular formula of hydrogen is 1 plus 1 into 2n plus 2, and that is equal to how much? 30. So from there what I'll get? 14n is equal to 28. Therefore n equal to 2. So means what I conclude? Whatever Y saturated hydrocarbon is there, the n value should be equal to 2. N value 2 means eth, and saturated hydrocarbon means ane. So name of the compound Y is what? It is ethane, and ethane formula is what? C2H6, and it is going to produce in the presence of nickel or palladium, that is catalyst, addition of hydrogen, and when the hydrogen is added, so it is going to convert the compound we have taken here is what? C2H4, ethene. Ethene plus hydrogen leads to formation of compound that is called as ethane. So we concluded X is what? X is our ethene. Y is what? Y is our ethane. And write the second part, write the structural formula of now. Okay, first part is done now. And now in the second part, this is how we can conclude the answer. Now the second part we are having, write the structural formula of butanone and pentanoic acid. So first we are having is what? Butanone. Butanone. But means N equal to 4, and on means we are having functional group of what? Ketone. And in ketone functional group, carbon atom itself is present. So I am writing here the functional group of ketone, that is C double bond O, and we know that both side some alkyl group must be there. So one carbon atom is already coming into the structure due to functional group. So how many carbon atom is left? 3. So we'll place these 3 carbon atom. It is your choice. You can place left side, right side. And the remaining valencies will be completed by what? Hydrogen. So it is what? Hydrogen, 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 hydrogen. And in this carbon atom already it is having 4 bonds complete. But this carbon atom, 3 more hydrogen are required, and this is what the structural formula of your butanone. This is the structural formula of butanone. Now the next structural formula we have to write for pentanoic acid, and for pentanoic acid the structural formula is what? Oic acid, carboxylic acid. The functional formula of carboxylic acid is COOH, and C is already coming in pentanoic acid due to the functional group. So first of all I will write the functional group COOH, C double bond OH, or we can directly write COH also. Pentanoic, pent means how many carbon atoms? 5. Pentanoic acid, pentanoic acid. So N equal to, for pentanoic, pent means 5 and oic acid means functional group we are having is COOH. The functional group I already placed COH, and the remaining valencies will be satisfied what? Hydrogen, 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 hydrogen. Hydrogen having 4 valency, everywhere valency should be satisfied. Here you can see that carbon valency is already satisfied, oxygen valency is already satisfied, hydrogen can form only single bond. So this is the structure of pentanoic acid, this is the structure of your butanone, this is pentanoic acid, and this is the structure of your butanone. So these are the structure of butanone and pentanoic acid. Next we are having, would you be able to check if water is hard by using the detergent? Give reason to justify your answer. So see, detergent, first thing is that we cannot use detergent to check hardness of the water. First of all, what is hard water? Hard water are that water which is having the excessive dissolved salts of calcium and magnesium, which is having high concentration of calcium and magnesium salts like calcium magnesium carbonates. So that is what our hard water. And soap, which can produce foam only in soft water, not in hard water. But detergent can produce lather or the foam in both soft as well as hard water. Therefore the detergent cannot be used to check the hardness whether the water is hard or the soft. Instead we can use soap. Why? Because the detergent is what? These are the detergents are the soluble. They can produce the soluble substances by reacting with the ionic part of your the magnesium and the calcium ions. They can react. Soap and detergent can react with the calcium magnesium ion and form the water soluble salts, the product. That's why it can form the foam also, and therefore we cannot use our detergent for checking the hardness of the water. So this is all about the soap and detergent, and few questions from there. So these are the reaction for the previous question. So I think these are the questions that we have discussed here from this carbonated compound. So this is a short discussion of the previous year questions from the carbonated compounds, and do not restrict your discussion practice only up to these questions. These are the few questions which are the highly probable type of question and repeated in multiple times. But beyond that, you can practice more questions from your the exemplar book, or you can discuss the previous year questions. You can take the sample paper also, and read NCERT very carefully, because in chemistry and physics they frame question directly from, they pick any of the line from the NCERT and they can frame the questions. Activities are very important in both physics and chemistry as well as bio also. So you should pay more attention to the activities also, and whatever experiment we have performed in the activities, whatever activities are given. So you should be well aware with the activities, what are the product of those activities, what are the conditions for performing those activities, because activity based questions they generally ask in chemistry. So this is a short video, informative video from our side, so that you can get the benefit from the previous year questions and to enhance your scores so that you can get scores of 90%. Thank you so much for joining, and we'll meet in the next video with the new content. Thank you so much.